In this lesson, we're going to take a look at how we solve a linear system, okay? And we're going to be doing it graphically, and that's the method that we ended off with in grade 9, okay? So we're going to review that basically today. And what we have to realize or remember that a system is basically a listing of two or more equations, and a linear system, all those equations are lines. So how we know that these are lines is basically we take a look at the degree or the exponent over top of our variables, the x and y. Since they are both 1, they're linear equations there. Okay, so anyhow, how do we determine the point of intersection? Basically, graphically is we graph each one on our coordinate system and then find the point of intersection. The point of intersection is the solution. So here's how we do that. The first thing I want you to do is we label each equation with equation 1 and equation 2. The circle around the equations in math means equation. Okay, so it's equation 1, equation 2. Then from equation 1, we're going to decide which method we're going to use in order to graph. So this one's set up pretty much for the intercept method. So what we're going to do is we're going to find the x-intercept first, and we know that the y is equal to 0. Since y is equal to 0, we substitute that into equation 1, and we're left with x equals 4. So what we'll do there is we'll just plot x equals 4 on the x-axis there, so we've got that there at 4, 0. Okay? The next thing is we need the y-intercept. So the y-intercept means that the x is equal to 0, so we substitute that in for the x, and we're left with 2y is equal to 4. When we solve for y, we get y is equal to 2. So again, we can plot that point on our graph there, all right? From here, what we're going to do is we're just going to draw out our line going through both points there, okay? What I'd like you to do is make sure that your line, you use a ruler and you extend past both points. Just because I'm doing this with a line tool, it's more accurate if I just start at one of the points and go through the next. Okay, so let's take a look at our second line. Okay, so from equation 2, we are now going to notice that it's in slope y-intercept form. So the slope we can see is 1 because it's the coefficient in front of the x, and the y-intercept is -1. What we want to do here is we want to plot the y-intercept first, which is at -1, and we'll put it right there at -1, and then use the slope to find the second point. So what we do is, because it's a 1, we go up 1 over 1 to the right. We go up 1 over 1 to the right, and we can see that we pretty much have our point of intersection right there. Again, we draw our line through the points. Okay. One last thing to do that you can do for extra communication skills is to label each line on the graph as equation 1 and equation 2 again. So what we think here is we're going to identify the point of intersection. We think it's the point 2, 1. What we're going to do is we're going to check with both equations to verify that it is 2, 1 there. So what we do is we say that we're going to check with equation 1. And so we have our x value of 2 plus 2 times our y value, which is 1, and that needs to be 4, and 2 plus 2 is 4, so we have that the left side equals right side. This point is on equation 1. In order for it to be a solution, we have to make sure that it's on equation 2. And so we substitute our values in. Equation 2 starts with the y, which is 1. And then we have an x, which is 2, minus 1. 2 minus 1 is 1. So again, we're set there. So now we can say that, therefore, the solution is the point 2, 1. In the next video, we'll take a look at the next example.